So in a previous video, we looked at what Wavefield synthesis is and how it works. You can watch that video if you want all the details, but the short version is it allows you to create the illusion of sound coming from anywhere you want, with some technical limitations, using just an array of speakers in front of you. Now it's time to take it to the next level and actually build an affordable DIY system to show it off. This will be a part of a two-part series, with the next video looking at how to actually produce content for the array. To start, let's go through the parts list. I selected the Dayton Audio PC105-4 4-inch full range driver for the system, which I will need 15 of. You can have as many as you want, it just changes the overall size of the array. As discussed in my previous Wavefield synthesis video, we want the drivers as close together as possible to reduce aliasing, which means utilizing smaller drivers, and we also want a full range driver. Since we're dividing sound in the spatial domain, we generally don't want to also divide it in the frequency domain with a crossover. With this driver and spacing, our aliasing frequency will be about 1300 Hz, which is pretty good. Research suggests that aliasing in that range isn't too noticeable since the shape of our outer ear causes filtering, which masks the aliasing, but we'll have to see how it behaves once everything is finished. The drivers will be driven by a Shure Electronics amplifier. That's Shure without the H, not the same company that makes the SM58. It's a 2-channel amplifier, so we'll need 8 of them. It can do 30 watts into the 4-ohm drivers we're using, which gives us a maximum SPL of about 100 dB at the listening position, which should be plenty for our purposes. It'll also be easy to upgrade the amps in the future if I ever decide I want more power, since the drivers can each handle up to 80 watts maximum. The amplifiers don't come with a power supply, so I'm using a 12-volt 350 watt power supply to power them all together. This will simplify power delivery a bit compared to using 8 different power bricks for each amplifier. In addition to the main array, I'm supplementing with a subwoofer, in this case an Atom T10S, but you could use anything. I realize I just said we don't want to use a frequency divided system, but these 4-inch drivers won't really be able to produce below about 125 Hz. I'm hoping that since lower frequencies can be harder to localize anyway, the effect won't really be noticeable. That's another item we'll have to explore later on. Driving it all is a Behringer X32 rack. This plus the X16 stage box gives us 16 outputs for the 15 drivers and 1 subwoofer. Realistically, you could use any interface for this piece and scale the array based on how many outputs you have. I just used this because it's the most outputs I could get from a single device with what I had already on hand. That's all the electronics, so let's quickly talk the enclosure. For the exterior, I'm using 1/2-inch by 6-inch boards. I got 8-foot lengths since my project will be a little bit longer than 6 feet, and then cut the boards down to size. I use 2 MDF boards since they look nicer for the top and front, and hardwood boards for the back and bottom since they're cheaper. You could use either or both for your project. I bought a 2 square foot panel of 1/4-inch plywood for the ends and dividers. This is a lot thinner than you'd normally use for a speaker, but we want to keep it thin to facilitate getting the speakers as close together as possible. I'll cut this into the 5-inch squares needed. I also purchased a roll of roofing felt, which we'll use to improve the damping of the dividers without adding a lot of thickness. For tools, you just need a drill and a saw. I'm using a jigsaw and a miter saw, but anything that cuts wood will work. All of this, including miscellaneous items like screws, wire, and glue, brings our total price for the speaker to just about $600. If you're buying everything from scratch, including interface, subwoofer, and tools, you're looking at closer to $3,000. Now let's build the darn thing. I'm not going to go too deep into the construction since this is a video about Wavefield synthesis and not about speaker building, but I will touch on the highlights. I recommend purchasing and reading the Loudspeaker Design Cookbook if you want a lot of detail about building speakers. To start, I marked out the spacing of the drivers. Each enclosure needs to be 5 cubic inches with 1/4 of an inch between each for the plywood dividers. Generally, you don't want to make enclosures perfect cubes, but with the scale I'm working at, it wasn't practical to do it differently. My cutouts for the speakers need to be 4 inches, so I found a cup with a rim that diameter to trace them out. I'm using a 4-inch hole dozer to cut the holes. You could use a router for this, but the hole dozer was convenient since the cutouts are a nice round number, and the dozer conveniently makes nice round holes. I did a quick dummy test fit with the drivers to check myself, and then moved on to the assembly. I'll show a diagram on screen with how I put the boards together. Since 6-inch wide boards are actually 5.5 inches wide, this is the easiest way to get the 5-inch square interior that I need. To assemble, I am wood gluing the boards together to help seal the gaps, then putting in 4 wood screws for improved damping and durability. I rounded off the front corner of my top piece. This is another optional step that will improve the edge diffraction characteristics of the enclosure. It's also just an excuse to use my router. I also painted the front and top boards black, which is purely for aesthetics. I'm using 1/2-inch screws to attach the drivers. If you want to go a bit fancier, you could use bolts and well nuts, which would give improved damping. That was originally the plan, but after realizing it would cost me $100 in well nuts, I decided to keep it simple. I'm attaching the drivers now, so when I add the dividers, I can make sure I'm not interfering with the driver placement at all, but I will take them out before final assembly so that they don't get covered in glue and dust. The dividers are made out of the 1/4-inch plywood cut into 5-inch squares. I'm also cutting 5-inch squares out of the roofing felt and gluing them to both sides of the plywood. This is another optional step, but it improves the damping and will help reduce sound leaking between the driver enclosures without adding a lot of thickness. With my dividers assembled, I can then glue them into place. This required a bit of extra effort since the boards I used weren't perfectly straight, but with some extra clamping and a big helping of wood glue, I was able to get an acceptable fit. With that and planting our final piece on top, the enclosure is just about complete. Each enclosure also gets a small piece of scrap wool batting. You could use any type of insulation for this, but I had some batting left over from my Yekling disc project. Now for the final wiring and assembly. I've got each of my amps wired in parallel to the power supply, so they're all getting a steady 12 volts. Technically, there's a slight voltage drop from cable resistance, but I was curious and I measured it and it only came out to 1/100th of a dB difference from the power supply to the last amp, so not a big deal. The output of each amp is going via speaker wire to each driver. I drilled a hole in the back of the enclosure for wire and then sealed it with caulk. This was an easier and cheaper solution than installing 15 separate speaker terminals. The important thing is to keep plenty of slack inside each enclosure, since removing the driver will be the only way to access the interior for repairs or modifications. With everything wired up, I did a quick dummy check by plugging my phone into each amp and verifying the output. That turned out to be a good idea because I didn't realize the second output on these amps has the polarity reversed. So I had every other channel wired out of polarity. This is why you check things. From there, I've got 16 XLR cables soldered to provide inputs from my X32 to each of the amps. And with that, we have a completed Wavefield synthesis system. I am going to bring it into my acoustically treated studio. We're going to use a measurement mic and EQ on the X32 to tune each of the outputs to make them all balanced. And then we'll take a listen. I have this just a music track, royalty-free music track pulled up that we're going to use as our reference. We're just going to kind of pan it around and see how it sounds. We are using, I'll show it on screen, a software called Spat Revolution. We'll talk about it more in the second video when we talk about how to produce content for something like this, but for now we're just going to go ahead and hit play, and you can see we've got just a little input here that I can kind of pan around and you can listen to. So I guess let's take a listen here and see how this sounds. So again, the cool thing about Wavefield synthesis is we can go, anywhere back here, but we can also come in front of the array here. So I can pull it up like right here. And I mean, it really sounds like it's coming from right here. It's not super convincing if I just kind of sit here, but again, the big advantage of Wavefield synthesis is I can go like here, and I'm still kind of getting the sound right here-ish. It's not perfect. Again, we talked about aliasing. As you get kind of like way off angle from a sound, you start to lose a little bit, but I can kind of still hear it somewhere around here. It does kind of pull out front from the array, and then I can go, let's say, like way off to the side. And if I do this way off to the side, I kind of lose a little bit. there's we talked about aliasing as a problem when the sound is like the sound waves are traveling parallel to the array. You kind of lose it a bit, and I can definitely hear going from here to here, the sound definitely, it doesn't really pull out way off to the side here, and it also gets a little thinner. You can, it's not super like kind of phasey like I might describe aliasing normally, but it definitely does get a bit like thinner. You lose some of those frequencies. Speaking of frequency, I am really glad I have the subwoofer. The subwoofer is working great. It sounds like adding a subwoofer to any other system. It's just adding that extra boost that you don't really get from a normal 2 or especially 1 channel system in this case. And then again, I just pan it, way back here. And sitting still, I don't feel like just sitting here there's really any difference from a 2 or a 3 channel system, I don't feel like I'm really gaining that much, but the advantage is, if I start to move around, that sound is still staying consistent. It's still staying in the same place, no matter how much I move around. So it really does have that advantage for any time there's an audience at all. But I mean, overall, the system sounds really great. I'm really happy with it. Especially, $600, it's not cheap by any means, but 15 drivers is a lot. And they sound great. They're only, $20 to $30 drivers each. And for them to sound this good, especially being a single channel, is really nice. So I'm really happy with it. I will point out one other thing in here. I can actually change the panning. So right now we're set to, of course, Wavefield synthesis, if I can remember. Here we go. So it's set to Wavefield synthesis. So the other type of panning, there's a few others, but the other big one is VBAP, vector-based amplitude panning. This is what most immersive systems use. This is kind of a fairly basic type of immersive panning. And I'll say, if I'm just panning a sound, left to right, just like this, I'll just say, the VBAP sounds better. It just sounds better for just, having a sound, at the array and just panning back and forth. It gives a smoother sound. But again, the advantage of going over here to our Wavefield synthesis panning, if I can turn on our Wavefield synthesis panning, is again you get the full quality of the spatialization no matter where you are. So anywhere in front of this array, I still get the same quality and I still get the ability to discern, exactly where a sound is. We'll talk a lot more about this when we actually get into the mixing, but the last thing I'll point out is I think Wavefield synthesis would work even better when the speakers are hidden. When you can see the speakers, your mind kind of like naturally associates the sound with the speaker because we know what speakers look like. We kind of naturally associate a sound with a speaker. So if the speakers are hidden, I think the effect would be even more convincing, especially for someone who wasn't as savvy as a listener. But overall, it still sounds really great. It still works really well. And definitely a really fun project, and definitely one worth trying out on your own if you're really into this. So, but yeah, that is it for this video. If you like this video, if you thought this was a fun, cool project, if you want to try it out for your own, hit that like button. If not, feel free to hit the dislike button. If you have any questions or comments about this project, you want to know more, definitely leave those down in the comment section down below. And if you want to see more videos, including that upcoming video on mixing content for this array, definitely hit that subscribe button.